Hello there, guys. Welcome to another video. Today's going to be our second day doing recapping the first unit, right? Today's concept is going to be similar triangles. Once again, I am being very strategic on which unit one concepts we're going over and on preparation for the semester one final, right? Reminder also that Wednesday will be the last day to do the revision assignments. All of those revision assignments will be the most crucial step in ensuring that you're preparing for the semester one final. So please, 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 even if you have a high GPA or you're confident with your homework category GPA as well, you should still go over those concepts because they will be needed on the semester one final. So let's go ahead and dive into today's lesson. So the question reads, to measure the distance D across the Whitney Pound, Lewis measured off the distance as shown below. Use the drawing to determine B. So right away, I see two triangles. And before we could just assume these triangles are similar, we must actually prove that these triangles are similar. So the first thing I kind of notice, and I'm going to go highlight it, that this angle 1 is a vertical angle to this angle right here. And I remember the concept, vertical angles are congruent. So even though this angle isn't measured, let's call this angle measure 6, right? So this lets us know that angle 1 is equal to angle 6. Another thing I noticed is that they both have right triangles. So this also lets me know that they have a second angle that is congruent. They both have right angles. So that is actually enough information for us to make the claim that these triangles are similar, because what this lets us know, sorry, that was ugly F. If two triangles have two congruent, which means equal, angles, then the third angle is also congruent. So this is enough of a claim for us to say that angle 4, let me use a different color, angle 4 will be congruent to angle 3. Thus, because all three angles are congruent, we can say these triangles are similar. And because they are similar, there is a scale factor. So it is our job to determine what that scale factor is. So one trick that this question is trying to do is that these angles are not orientated in the same way. So I'm actually going to first do that, right? So this is our, that's not what I wanted to do. So this is going to be our bigger triangle right here. And we have that this is the right angle. This is angle D. Side length D, and we are told this is 80 yards. Now I'm going to go ahead and draw the smaller angle, but reorientate it so it is facing the same direction as our bigger triangle. So, a little highlighting. So boom, sorry, I know these are not the neatest right triangles, I apologize. So if this is a right angle right here, then that will mean that angle 3 will be up here and angle 1 will be down here, because we know angle 1 is congruent to angle 6, which is right there. So if this is going to be angle 1, that means this is going to be our side of 5 yards. And then this will be our side of 4 yards. So what we have to do to determine the side length of D, we need to figure out what is our scale factor. So what is the value that we're taking to get from this side length to this side length? So a quick division, 80 divided by 5 will help us determine that. So 80 divided by 5, that is going to be 16. And that is going to be our scale factor. So in order to now determine the side length of D, we need to use that same scale factor on this side length. So all we have to do is go ahead and do 16 times 4. Let me use a different color. So we're going to do 16, wrong button. I'm going to go ahead and do 16 times 4. So 6 times 4 is 24, carry the 2. 4 times 2 is 4, plus 2 is 64. So remember, don't forget units. This is going to be a side length of 64 yards. But it's very important that we do double check. So how do we double check? Well, because there's a scale factor, that means these side lengths must be proportional. So on the smaller triangle, we have the proportion 4/5, and this must equal to 64 over 80. And a quick check on our calculators, we can see if that is in fact equal to each other. And 64 divided by 80 is equal to 0.8. And 4 divided by 5 is also equal to 0.8. So we successfully found the length of side length D. So for today, you're going to go ahead and do another similar triangle problem. But remember, you must double check and please utilize putting units as well. That is just a simple bare minimum effort, but that gets you points on exams, making sure that you put your units. So you have one more independent practice problem, and then you will also have an exit ticket today as well. Thanks, guys.